So a percent represents a ratio or fraction out of 100. For example, if you got 89% as a mark in math class, that means that on average you get 89 out of every 100 things correct. That's what that means. Okay? And today what we're going to be doing is looking at the relationship between a fraction and a percent, as well as a decimal and a percent. Now, because the topic of today is percents, we're not going to worry about how fractions relate to decimals, but they do. These are all three different representations of the same kind of thing. So hypothetically speaking, I could say, well, you got, let's say, I'll use an easy number for me, 22 out of 33 on the test yesterday. That's a fraction. Now, as a decimal, that would be 0.66666666666 repeated, okay? As a percent, that would be 67% if we round it, or 66.6666666%. So we can represent the same thing three different ways, as a fraction, as a decimal, or as a percent. And I suppose it might depend what we are referring to, but based on what we're referring to, there will be a time and place where the fraction is the most appropriate, the decimal might be the most appropriate, or the percent might be most appropriate. Okay? So, example, we are going to change fractions into percents. We are going to change fractions into percents. So, if you have 3 out of 10, what would that be as a percent?
It would be 30%.
It would be. How'd you get it?
I did 3 divided by 10, which is 0.3, times that by 100 is 30.
Fantastic. Absolutely. So 3 divided by a 10, and why'd you multiply by 100? Right, percent means out of 100. So you converted it to a decimal. That's what 3 divided by 10 does. And then you know that a percent's out of 100, so you multiply it by 100. Bob's your uncle, it's 30%. Cool, I can get down with that. 30%. All right? Now, what about 4 out of 5? What's 4 out of 5? And what do you think?
80.
Beautiful. Yeah. And you know what? Like, I got zero issues with what Jordy said as far as finding out as a percent. But I'm just going to show you maybe a different way. Not a better way, a different way. If we want to get this to be out of 100, what we have to ask ourselves is, how many times does 5 go into 100?
20 times.
What's that?
20 times.
Beautiful. So we're going to multiply it by 20. So we're going to do the same thing with the top number. We're going to go 4 times 20, and 4 times 20 is 80. So therefore it's 80%, because anything over 100, that's a percent. Again, I'm not saying this is a better way. It's a different way. It's a different way to arrive at the same thing. So 4 out of 5 is 80%. That's absolutely correct. Okay? So there we go. There is our first 2 questions done. Now, what about if we want to take a percent and turn it into a fraction and in lowest terms? Whenever we deal with fractions, there's that F word again. Whenever we deal with fractions, we want to try and put our fractions in lowest terms. The reason for that is it just makes more sense, okay? Just makes more sense. It's easier to digest if things are in simplest terms, okay? So hypothetically speaking, let's say I tally up all the quizzes during the semester, and I say to Jordy, you got 220 out of 240 on all your quizzes. Now, if I just say that, you're like, well, okay. But now if I say, well, you got 11 out of 12, which is that fraction simplified, 11 out of 12 is easier for us to think about because the numbers are smaller and more manageable. But not all fractions can be reduced. But if they can be, it just makes our lives a little bit easier. Okay? So, 8%. Now, as a fraction, that would be 8 over 100, because it's whatever the percent is over 100. But then we have to ask ourselves the million-dollar question: what goes into 8 and 100? What number goes into 8 and 100?
4.
Beautiful. 2 works. 4 is a little bit better because it's bigger. You can do 2, and then you'd have to do 2 again. 4 will just get us there a little quicker. How many 4s go into 8? 2. How many 4s go into 100?
25.
Beautiful. So the answer is 2 over 25 if we write it in simplest form, okay? Whenever I ask you for a fraction, like this example does, simplest or lowest terms is always what I am looking for, okay? So these take a little longer because we have to try and reduce them if we can. 72%, I'll give you this, it's 72 over 100. What would that be simplified? What goes into 72 and 100? So if you divide by 2, you end up with 36 over 50. Now I'm going to tell you this, we're not done. How do I know we're not done?
It's not the simplest.
Right, but how do I know that? 36 and 50 are both even numbers. Even numbers, as we recall, are any numbers that end with a 0, a 2, a 4, a 6, or an 8. Even numbers can always be divided by what number? 2. So we can divide these numbers by 2 again, which means that the original fraction could have been divided by 4. But I'm just illustrating that if you don't start with 4, that's okay. You just have to do an extra step. So if we divide 36 and 50 both by 2, what do we get?
Over 25.
18 over 25. Nicely done. And there we go. So that's 72%. So if you got 18 out of 25 on a test or an assignment or a quiz or whatever the heck, that's going to be the equivalent of 72%. Okay? Question B, 30%. Now this is a are you paying attention? Because we already did a question where we had a fraction that gave us 30%. What was it? 3 over 10, right. And because there's a 0 here, we can just consider the 3, and we can just put it over 10. Now, there's no shame in saying 30 over 100. There's no shame in that, but then you're going to have to divide both of those numbers by 10, and you'll still get to 3 over 10. So 3 over 10 is the equivalent fraction to 30%. And again, I just want to stress that when you write as a fraction, some of them will not be able to be put in simplest terms. Although the ones I'm looking at here will be able to be. So they will all have some kind of simplest form. Okay, so 125%. This is interesting. What do you think this one might be as a fraction? 125%.
In simplest form, all the way down.
No, just the introductory part.
Are we 125 over 1,000?
Over,
1,000? No? 100?
still over 100. Okay, still over 100. If you put it over 1,000, then you're looking at 12.5%. So if we have 125 over 100, what can we divide into 125 and into 100? 5, but also, did I hear a bigger number? 25. 5 works. 25 works a little bit nicer because it gets us there a little quicker. So how many 25s are there in 100? In 100?
Oh, no.
4? In 125?
5.
5. So it's 5 over 4 for an answer. So 5 over 4 is the equivalent of 125%. So if you get a percent that's over 100, then it means that the top number, whatever it is going to be bigger than the bottom number, because 100% means basically 1 over 1. So if it's over 100%, then the top number is going to be bigger than the bottom number. We have a couple more examples here. Now these ones actually are really pretty straightforward actually. When we multiply by powers of 10, and specifically I'm thinking about the staircase, when we went from like meters to centimeters, or we went from millimeters to decameters, we played with the idea of multiplying by 10, 100, 1,000, dividing by 10, 100, 1,000, and we're doing the same thing here. In this question, what we're looking at is we're taking a decimal and we're turning it into a percent. So in order to do that, I could just tell you straight up, we're multiplying all of these by 100. Thank you. Yeah, 100. We're multiplying these all by 100. Yes?
What about the C?
It's a good question. You're talking about this one right here? It's a good question. We'll get there. But first, I want to just stress one thing. And if you don't like what I'm about to show you, if it doesn't work for you, then don't use it. Okay? But multiplying by 100 is equivalent to taking the decimal and moving to the right 2 spots. If you move the decimal over 2 spots to the right, that's the equivalent of multiplying by 100. Now, why am I telling you that? Well, because I think it's easier to move the decimal 2 spots than to start punching things into a calculator. There's nothing wrong with using a calculator. Nothing at all. But if we can do it quicker and easier, then I'm all for that too. Okay? So let's look at our questions here. So let's look at 0.3. If we were to move the decimal over 2 spots to the right, what percent do we get? 30%. Very good. How about for 0.21? What would that be as a percent? Fantastic. 21%. You move the decimal over 2 spots, and it just becomes 21%. Now Kyle asked, well, what happens with C? I'm guessing you asked about C because there's 3 digits after the decimal. Is that why? Okay. What do you think you get if you move the decimal over 2 spots? 50.5. Beautiful. You move it over once, you move it over twice, it ends here, so it goes right here. So that means you have 50.5%, and that's all she wrote for that one. Now we have 3 questions over to the right. And so we're going to move over 2 spots. What do we get here? 4%. How about question E? What do we get there?
160.
Beautiful, 160%. Sometimes it's easy to forget about the 0, but you have to include it, and it's 160%. Last but not least, we got this monstrosity here. What does it become as a percent?
Would be 304.5%.
Yep. Thank you very much for everyone that responded. We get 304.5% for that. And again, we get there by moving the decimal over 2 spots. Now, if you think to yourself and you say, hey, I don't like this moving decimal business, then just throw these into your calculator and multiply by 100. You will accomplish the exact same thing. You'll get the same place, no problem, by multiplying by 100. Now, if we want to change the percents into decimals, then what we are effectively doing in the next set of examples is the exact opposite of what we did in the first set of examples on this page. So if we were turning them into percents, we multiplied by 100. What do you think we might do to take a percent and turn it into a decimal? Divide by 100. Beautiful. Spot on. So we're going to divide by 100. And my little shortcut, which isn't really mine, but it's a way of looking at it, is moving the decimal over to the right 2 spots. How do you think we might move the decimal over when we're going from a percent into a decimal? To the left. Perfect. So instead of taking the decimal and moving it to the right, we're going to take the decimal and move it to the left 2 spots. Okay. So let's look at 36%. What does that become as a decimal?
Oh, that'll be 0.36.
Fantastic. 0.36. Good stuff. How about 8%? Great. You did not forget about that 0 in the middle. If you go over 2 spots, there does need to be a 0 there. It's 0.08. Sometimes that's easy to miss. And we have 120%. What does that become? 1.2. Super. The last 3 are a little trickier. We'll start off with 5.75%. What might that become?
0.0575.
Fantastic. Now, the last 2, we have to do a little bit of thinking. If you have a half, what would that be as a decimal? 0.5. So this means 4.5%. So if it's 4.5%, what would that be as a decimal?
Zero 0.45.
That? Is this what you want, Kyle?
Yeah.
Okay. There's something not quite right here. What is that?
Oh, the decimal place is in the wrong.
The decimal's in the wrong spot?
Yeah.
Where? Okay, so I'm going to... There we go. Let me do this. See if I can do this. Perfect. Where does the decimal need to go?
In between the 2 zeros.
In between the 2 zeros. It goes right there. So the answer is 0.045. Good catch. Last one. We have 67 4/5 of a percent. To know this, we have to have an idea of what 4/5 is as a decimal. What's 4 over 5 as a decimal?
0.8.
0.8. Good stuff. So that means that this is 67. Oopsies, that's not a 7. 67.8%. What would that be as a decimal?
0.678.
Fantastic. 0.678. And that is it for that.